Hello friends. Hello friends. Welcome to C# Intermediate to Advanced tutorial. Now we will implement the top portion of the example. That means here we will be creating a class called point2d or CLS point. Then we will implement ICloneable interface on the point. Then we will experiment the copy and clone operations. These are all the slide decks from previous parts. So here if you see, first we create a class called cPoint2d. So it contains two member x and y, and the data type is integer. That means the class point2d contains two member and both the members are value types. Next, here in this location we have properties to read and write this x. We have a public property called cx, and we have get and set version. So get version is to read the content of this x, and set version is to assign a value to x. Similarly, we have a property for this y also. After that, here you can notice we implement ICloneable interface on a class CLS point2d. Here in the clone method, we simply make a call to MemberwiseClone method. This dot MemberwiseClone, and whatever it returns, and we are returning that to the caller. The return type here is object. So what happens, usually it will get called like this. Say for example, this is the class name, right? CLS. Right. So let's assume that P1 was already constructed, and you will simply make a call to P1.clone. So, and it will get assigned to P2. So what happens, the data movement is from P1 to P2. So let's say P1, or this is the heap location pointed by P1, and let's say the content of x is 20 and content of y is 15. Since this is a value type, the content in the cell itself a value. That means it doesn't point some other address. Alright, so here clone p1.clone, that's what we are calling. So it will make a call to this clone method, and inside we are doing the MemberwiseClone. So what happens, the source here is P1 and the destination is P2. The content will get copied to P2. So if you see, this is actually a shallow copy, but since the members are value type, even though it performs bit pattern copy, after the bit pattern copy, if you see, we will have the value 20 here in this cell, and we will have value 15 here. So it's not reference type, it's a value type. So this MemberwiseClone will work well here. So later, if user changes the value of y through P2, say 15 to 10, if they change, it just reflects on P2 only. There is no effect of P1. Why? Because they all have its own room. P1 has two compartment and P2 has two compartment, and you changed a value 10 here in the second compartment or in the Y cell of P2. So it doesn't do anything, or it doesn't do any harm to Y in the P1 because all are value type. Alright, now we are done with our clone, and here if you see, since we made a call to MemberwiseClone method, all the members will get copied. So this one you can implement like you can create a new instance, then inside that new instance you can manually copy X and Y. You can do that way also. But the MemberwiseClone, what it will do, once again I will reiterate. First it will create the instance P2. That's the first step. This MemberwiseClone, I mean, it creates new instance, then it performs a bit pattern copy. That's the second step. After that it returns the new instance. So this is the new instance, right? P2. It will return that, or this heap location it will return, and we will return that to the caller. Here this is the caller, and returned heap location is copied to P2. So now we have our class ready, that means CLS.2D. Then we are coming inside this form. This is the form, right? From IClone. Then here we declared 3 point reference, point 1, point 2, point 3. So all these point 1, point 2, point 3 are reference type, and here if you see, we created only one instance in the heap because we use a new keyword, and point 2 and point 3 are storing null. Only point 1 is storing some address. Why? Because here the step goes like this: some instance created on heap and its address is stored on point 1. So in the btn set click, so we read the content of this txtx.txt into .parse, and then we are making call to our classes public property cx. So this will populate the structure, I mean it will populate the member x on the point. Then cy, this will populate the member y, and it reads the value from txty. So after populating the class instance member point 1, if you see, it was already constructed. Then we empty these two checkboxes. Then we make a call to refresh point. This one we will see later. Refresh point will do nothing but it will populate the labels here. So in the previous video we forgot to see these label names. In the next slide you will see name for the label. Next, btn set copy. This is the one, btn set copy. We do the same stuff, but this time we assign the content, I mean we populate the point 2. So point 2, if you see here, it is null. That means if you directly click here, you will get error. You have to perform it in a sequence. So first you have to set, then you have to perform copy, then you have to perform clone. After that we can use these set buttons. So it doesn't do any validation because here we are simply learning, but in real world you should always check whether point 2 is null. If it is null, don't do anything, otherwise you can populate. But here, since it's just for experimenting purpose, we don't have such a validation, and in btn set we are setting the points 2's x and y coordinate values by taking the input from txt copy x and txt copy y. Alright, then this is txt clone x and this one is txt clone y. and in btn set clone, this is the button btn set clone, and in its click event we are populating x and y coordinate of 0.3. Then we are making call to refresh point. So if you see in all the 3 button click, we are making call to refresh points. After this, in the copy click, if you see here, we are doing the assignment operation. Point 1 was already constructed, and we are assigning the content of point 1 to point 2. After that, LBL info copy. This is the LBL info copy, and here we are just showing the content of the point. So we show it like for example 12,6. So this is how we are showing the point. Then we are making call to refresh point also. There also we do the same stuff. Maybe this is not required. Anyhow, we are just showing this. If you see, this is our class point 2D. You already saw there is a field x and y, and this is public property cx and cy, and it has a clone method because it implements ICloneable interface. Now let's experiment how this point 1 and point 2 assignment operator works. We know that our form itself a class instance, so that will get created on the heap. Let's say this is FRM. I'll just cross check it. FRM IClone. FRM IClone is created on the heap, and it contains point 1 which we already created. Point 1 contains 2 cell, and for example let us say this is 10 and another one is also 10, and this is the form IClone, right? In form IClone we have 3 member P1, P2 and P3. So P1 already stores 0x, and this is P2. If you see here, what we are doing from P1, we are copying the content to P2. That means P1's content is 0x and we are copying it here, right? P1, P2, P3 are members of our form, and since we created P1 in the class level itself with the new keyword, only one heap location exists. And here if you see, we doesn't create any heap location, we are just copying the content from P1 to P2. P1 to P2. So what happens, P1 points to this heap location, and P2 also points to the same heap location. P1 and P2 both are pointing to the same heap location. So after the copy click, we make a call to refresh point. That means after the copy, all the 3 points will get refreshed. And when refresh happens, let's say first you set point 10, 10, and you will be seeing 10, 10 like this here. And after you do copy, you will be seeing 10, 10. Why? Because here we will read the content from P2 reference, P2 also pointing to the same location, so you will see 10,10 here. Next, in btn clone click, point 1, we already have point 1, right? Point 1, this is the point 1, and it points to some heap location. Dot clone, here we are making call to the clone method, and we know that this clone method will make a call to this clone, and it will make a call to this dot MemberwiseClone. So this represents point 1 dot MemberwiseClone. We know that MemberwiseClone will create a new instance, performs bit pattern copy, the content get copied here, and this content get copied here, and we will be having 10 here, and we will be having 10 here. So let's say the address here is 0y, and 0y is returned by this clone. Remember, in clone method we have a statement like return this dot MemberwiseClone. MemberwiseClone will create a new instance on the heap, performs a copy, because we are making call to point 1 dot clone, so that means MemberwiseClone will do a copy. Source is this is here point 1. From here it will copy the content to the new instance, and that new instance will get returned to the caller. So the returned instance, we are typecasting it to point 2d, and we are storing that here in point 3. And in point 3, if you see, this location is new, so we will be having 0y. That means this is now not pointing to the memory location 0x, it is pointing to a new memory location 0y, this P3. Point 3, here I just denoted it as a P3. Alright, so just remember this structure. In a refresh point, if you see, we access the point using the references. Here if you see, we have 3 reference, point 1 through point 1, P1. These are all the 3 members of the form, right? So on refresh point, we read all 3 members, point 1, point 2 and point 3, and print its contents on the corresponding placeholder. Alright, that's all the code required here. Now we will go ahead and experiment and see how it, the assignment operator as well as clone works. Now it is demo time. So this is our form, we previously saw it. So here there is a placeholder for a label. You can see that through document outline. LBN info clone, that is here. LBL info copy, that label is here. And there is one more label, LBL info, that's here. Alright, first what we will do, these 3 label name, I forgot to talk about this in the previous video. That's why I just shown these 3 label. And now we are at a class view, or you can even go to Solution Explorer, right click the project name, choose add class. We will name this as CLS point 2D, and you can see the class is added here. And let's save this, rebuild the solution. there is no error at this moment. Here we derive our class from, we say that C class point2D implements ICloneable interface. The class contains two members, as we already saw, integer x and integer y. Then we have a public property to access these x and y. So this is cx, which operates on the variable x, and cy, which operates on the data member y using the get and set. So at this stage, if we save and build our solution, you will be seeing an error stating that ICloneable x.2t does not implement interface member clone method it is asking to implement. So now this is the clone method, and inside the clone method, if you see, we are making call to MemberwiseClone, and here the tooltip shows that it creates a shallow copy of the current system object. So now you know the meaning of shallow copy. So just by reading the tooltip, now you know it performs bit pattern copy, and you know what are all the problem it will pose when the members are reference type. Here luckily we have value type, and when we learn about check shallow and deep, at that time we will use a reference type. For now, in this video we will just talk about value type, and we will see the difference between assigning it using the equal to operator and using the clone method, how the object behaves. So that's what we are going to study here in this video. Now let's build this once again. Now our class point2D is ready. Next, in our form instance, this is our form, right? So this is the constructor. So before the constructor, as a class member, we will add three instances for point. So point one we already constructed in the sense we created an instance using the new keyword. That means here an object will be created on the heap, and we store that heap location in the reference variable point one, and that reference variable is taking a place in the memory layout of form IClone. So this is btn set, right? We'll double click here, and we land up into the click event, and here if you see, we are doing the pausing, and we are assigning the point one. Here we make use of cx, and we know cx will do the set, and it will assign a value here. So this is a btn set copy. The code will be similar, and if you see here, we are populating the point one, and here we are populating point two. Now we will implement a click handler for btn set clone, and we populate the third point here. Next we will go to btn copy. Here if you see, we perform the copy operation based on this assignment operator. Content from point one, from this heap location, it will get copied to point two, and here there is no new keyword. That means there is no new object created on the heap, but instead point 1 and point 2 both refer this single instance. We saw how it get performed by means of a bit pattern copy, or this is one more example for the shallow copy. Here bit patterns are copied from point 1 to point 2. So the address location that presents here will get present on point 2 also. That means both will have same address location. That means both will point to the already created instance. Now we will go ahead with the clone. So btn clone click. Here we perform the copy via assignment. Source is point 1, destination is point 2. Copy is done through assignment. Here source is point 1, destination is point 3. Instead of assignment, here we are making use of clone. Clone will go here and it will make a call to this clone, and inside clone we do the memberwise copy. But what this memberwise clone will do, it will create a new instance. So that's the difference. So after the memberwise clone, there will be a new heap location, but here even though we doesn't use new, the memberwise clone will perform a new C class point 2d. Then it will perform the copy also from point 1. It will perform a memberwise copy, and then it returns, and the return value we are storing it here in point 3. That means in point 3 we have some address location. That address location is not this one, because a new heap is created on this memberwise clone. Okay, finally we will create a refresh point. Why? Because if you see, we haven't yet implemented refresh point. If you build, you will be getting an error stating a refresh point is not in the context. So here is the refresh point, and here we are updating the point content lbl info, lbl copy, and lbl clone by reading the point values point 1, point 2, point 3. lbl info copy, and lbl info clone, all these are present on this location. Alright, now we will run this. First let us set a point 5 and 6, and it shows point 1 is 5,6. Now I am doing the copy. When we do a copy, point 1 and point 2 will point to the same memory location, and when we do the refresh, here you are seeing 5,6, point 2 also 5,6, but point 1 and point 2, both the reference variable is pointing to a same heap location. But when you do clone, memberwise clone will return a new instance. Then it performs content copy, and even though this is here, it is a new memory location and the cells are copied here. Alright, now we will set a new point here, 7, 7, and if I click set here, this will, we know that this set will modify the point 2's x and y, right? So this point 2 is pointing to the heap location, which is also pointed by this point 1. Why? Because point 1 and point 2 both share the same location, but since it is a cloned one, the memberwise clone created a new heap location, so this one is different. So when I click set, after setting the point 2, all points get refreshed, right? Now you will see both reads 7. Why? Because point 1, when we read the content from point 1, it goes to the memory location which is pointed by the second point. So here we updated the point through 0.2 reference, then when we read the value through 0.1 reference, since the location is same, we are getting 7,7. And here if you see, since we did the member-wise clone here we are not reading 7,7. Let's see, now I'm changing the content here to 9, 10, set. So this is independent and it is not touching 0.1 or 0.2. Even if I change something here through 0.1, it reflects on 0.2 also, because these two are same memory location, right? Or because we used the assignment operator, and this assignment doesn't create a new heap location. 0.2 was previously null, now it is holding the address which is present in 0.1. That means 0.1 and 0.2 is a reference for same heap location. But here, since we called member-wise-clone creates a new instance, then it performs a copy. XL from P1 is copied to P3, 0.3. YCell from 0.1 is copied to 0.3. That's why when we are experimenting it, you see this one is always independent. See, 9.9,10 is not disturbed. That's all here. In the next video, we will see how to implement the clone method when the containment is reference. So here it is value type, right? It is integer and this one is integer. So in the next video, we are going to create a class called line, and line will have instance of this point 2D. Thereby line contains reference type. Here point 2D contains value type and line will contain reference type, and we will see how to use the clone method on a line object. That we will do in the next video. So that's all here. Thank you for watching. Bye.